Okay, second part of kind of the foundations part of Algebra 2 really is going to go, this is going to be a lot of Algebra 1, okay, and a lot of things that you've already seen before, maybe just expanded slightly, okay. A lot of what we're going to do is dealing with functions and their graphs, and then especially slope, line, equations of lines in standard form, slope-intercept form. We'll get into scatter plots a little bit, and then we will finish up with absolute value. It's about 2 weeks. You can look at the Google Calendar, or you can look at the Google Sheet to kind of see about when we're going through, but it's roughly 2 weeks. Okay, somewhere right under that time frame, okay, or maybe just over. So whenever we deal with functions and their graphs, the biggest thing that we're going to talk about that is maybe or maybe not new is whenever we deal with the domain and range. Okay, a lot of what you do, a function is just a relation in which there is exactly one output for each input. Okay? You can't get two different answers for the same input value. If you think about it, if you have how many of you have a part-time job or a job that pays hourly? Okay? If you and your friend both work and you both get paid the same amount of money, okay? You both get paid $9 an hour, and then you both work 40 hours a week, what should you know about your paychecks? They should be the same. Okay? What happens if they're not? Somebody's getting screwed over, right? Okay? Either you or your friend. Okay? Somebody's not doing something right and things aren't going well. Okay? At least for one of you. Maybe you're the one getting paid extra, or maybe they're not getting paid enough. Who knows? So whenever we have that, you have the domain or the input values. That's like your hours that you work. Okay, so if you think about it, your domain or your input values, that's your x value, or your x coordinate, or your independent variable. Okay, those are, if you think about an hourly paying job, those are the hours that you put into your job. Whereas the range is then your output values. Okay, they are the ones that are your y coordinates or your dependent variable. They are dependent on your paycheck, or your amount that you get paid is dependent on how many hours you work. Okay, especially if it's an hourly paying job. But whenever we talk about domain and range, your domain deals with all of your x values, your range deals with all of your y values. You always look at your domain values as left and right, okay, in terms of where your graph is going or where it's been. And your range values are your horizontal, it's going horizontally, or excuse me, vertically, and like up and down, like from where it's going or where it's been. You always write it from least to greatest. Okay, just like we talked about with interval notation, if it's going to the left, we start with negative infinity and we go up until a certain value. If it's going up or going towards positive infinity, then we go from wherever our value is to positive infinity. So the domain and range, if I have my different values, now you don't have those on here, so I'll try to help you out as far as where they should be plotted. So my first point here is at, if I'm just going left to right, is going to be at -1, 0. Up top I have a spot at 0, 3. Then I'm at 2, 1. And down here at 1, -3. So in terms of my domain and range, what are my domain values? What are all the x values that fit on this graph? From least to greatest. Yeah. Mac. -1, 0, 1, and 2, right? Now, it doesn't include all the points in between those. It just includes those various points. So, as far as my domain is concerned, my domain is just going to be, I'm just going to write like my little bracket here, -1, 0, 1, and 2. What are my range values? What values do my y values hit? Again, from least to greatest. What's my lowest y value? -3. Then where? 0. And then 3. Okay, so I have one input for each output. So then, is the relation a function? So how do we check to see if a relation is a function? It's real simple. Okay, you remember doing what's called the vertical line test? Okay, vertical line test is going to make sure that if we draw a vertical line and I hit more than one value, okay, everybody knows what a vertical line is. If I draw vertical lines and I hit more than one spot of my functions, okay, if I hit more than one point, then it's not going to be a function. If I only hit one spot on my line or on my graph or on my points, then it's a function. Everything's okay. Now, another way to write this is by mapping. Okay? Yes, ma'am. Yes, that would be considered a function. Okay, because it doesn't hit more than one spot with the vertical line. So the second way of writing, one is to look at it as a graph and use the vertical line test. The second way is going to be with mapping. Okay, that means all of your x values go to your y value. So if I have a point from -3 as far as my x and it goes to +3, that's okay. Whereas the next point goes from 1 to -2 and from 1 to 1. What's the problem right here in the middle? Huh? It has two outputs, right? That's like if you and your friend both work 1 hour of your job. It's like telling them, well, you've got to give back you have to give back $2, and then your friend gets everything that they're supposed to. Does that seem right? No, there's an issue. Now, what's the difference though over here? Is this okay? Is the second part okay for the second one versus the first one? Yeah, you can have two domains have the same y value. Okay? If I have two different people that work the same different amount of hours, can they get paid the same amount of money? Yeah, how come?
Some people get paid more.
Right, some people get paid more. Okay? Some people have been at a job longer and they get paid more. They don't have to work as many hours as somebody else that gets paid less. Okay? We still write everything the same way. We'll still write the domain, and I'm just going to abbreviate it with a capital D, and I'm still just going to list my points of -3, 1, and 4, and then do the same thing with the range, and have -2, 3, or excuse me, 1, 3, and 4. Now, you should never have more range values than you do domain values. So if it asks, is it a function? No, it's not a function because I should never have more range values than domain values. I should never have more y's than x's. Okay? If I do, that means I have 2 points that are essentially stacked on top of each other. Okay? Or mapped from the same value. Same way with my domain of my second value. -3, 1, 3, and 4. And then my range is just 1, 2, and 3. Or is this relation a function? So, is this graph a function? Yeah. How do you know? Because it's a straight line, right? It passes vertical line test. And there's a poster right up here that says identity function. Okay, it's a straight line. So, easy way to always check is to say, well, does it pass vertical line test? Well, if I would just draw vertical lines here and go straight down, yeah, it's going to pass. Okay, it only hits 1 point on those vertical lines. Now, one thing that there is not anything of is, what is my domain and my range? Where does my domain value, where do my x values come from, or where are they going, and where are they ending up? Which direction? Do they ever stop moving? No. Even if I look, I could basically extend this line here in red, and it's just going to keep going this direction, right? All the way off the page. Same way as if I basically took it and it just kept going off the page there. Just because it doesn't stop, or it stops on the picture that you can see, doesn't mean that it stops moving. So as far as my x values, does it keep going to the left? Yes? So what value does it keep moving towards to the left side? Negative infinity. What about to the right side? Positive infinity. So my domain here is negative infinity to positive infinity. Okay, this is just something you're going to need to add in. Now, what about my range? Where's it going? Is it any different? No. So what's my range? Negative infinity to positive infinity. I'll give you a hint. Anytime you deal with domain and range of a linear function, it will always be negative infinity to positive infinity. Okay, for the domain and the range. If you do not get that on a test, okay, here's what I want you to do. Okay, everybody put up your right hand. If you're left-handed, put up your left hand. Cup it a little bit. Okay, so you're going to bend at the elbow to where it's right behind your, no, all the way down to your neck. Okay, this is if you don't do this. No, take it. You should look like me. Okay, look, my elbow's pointing out, not forward. There you go. Okay, so if you do not get this right on the test, okay, here's what you're going to do. You're going to take your hand right there. Okay? You should never miss this. And as we get further along into that, okay, there are other ones that you should never miss, because it will always, always, always be negative infinity to positive infinity for the domain and the range of a linear function. Always. Every day of the week and twice on Sundays. Now, in this one, or the one that's on the bottom right, is this a function? No. Okay, why not? It doesn't pass vertical line test, right? It hits at 2 places. Okay, so it's not a function. Now, we still want to figure out what's the domain and what's the range. So, where do as far as domain, what's the lowest x value or the smallest x value on my graph? 0. Is 0 included? Is it on 0? Yes. Okay. So if it is included, what kind of, is it going to be a parenthesis or a bracket? It's going to be a bracket. So from 0 to, where's it going? Positive infinity. It just keeps going to the right. Okay? Even if it's not a function, it's still going to have a domain and range. Okay? That's okay. So it goes from 0 to positive infinity. Parenthesis with the positive infinity. Now, what about my range? What does it keep doing? Does it ever stop? Let's look at it that way. No, it keeps going down, and it also keeps going up. It may not travel as much, but if I just keep extending it, it's just going to keep going up and up and up. Same way on the bottom side of the parabola, it's going to keep going down and down and down. Okay? So in this case, it's going to go from negative infinity to positive infinity. You have to write it as an ordered, when you have to write it as an ordered pair, remember, these are your x values, these are your y. Okay? All I'm going to do, I'm going to have my points, it's going to be negative 3 to positive 3. Then I'm going to have a point at 1, negative 2, and I'm going to have a point 1, 1, and then 4, 4. If it's listed as ordered pairs, it's real simple. If you have two x values that repeat themselves, then these two numbers right here and right there better match. If they don't match, it's not a function. Okay? If you have x values or input values or domain values, whatever word you want to use, if they match, or you have two that repeat themselves, then these two y coordinates better repeat themselves too. Okay, we've already talked about this one's not a function and the second one is. Okay, but if you have it written out as an ordered pair, if you have two x values that match, then your y values dang well better match. Okay. So whenever we have, it says a function can also be written as an equation. Okay, I'll give you a hint. If there's an f, if it's called f of x, if there's an f of x or a g of x or an h of x, okay, whatever letter you have right here where that f is, and it's of an x value, okay, that just means of, then it's going to be a function. Okay, if it's y equals, it's just an expression or an equation. But if it says f of x and it has the little f with the parentheses and the x in the middle, then it is a function every day of the week. Okay? Y and f of x are interchangeable, but know that if it says f of x, then it's automatically a function, or g of x or k of x, whatever letter that they're using. Okay? Like I said, it just tells you that it is a function. You should know how to graph lines. Okay? You can either plug and chug, right? This is stuff. You can make a table if you want. You can graph points until you see a pattern. Okay? You're probably going to use connect the points with a curve or a line depending on what it's doing. Okay? If it's a straight line, obviously, you're probably just going to look for the y-intercept and then just use the slope. Okay? But in some cases, if it's a curve, you may have to plug and chug and go from there. You know, if I have 2x minus 3, what are you going to do to graph it? Where are you actually? Are you going to put a problem like this in a table? No. What are you going to do? Where are you going to start at? You're going to start at negative 3, and then what are you going to do? What's your slope? 2. So what am I going to do? From that negative 3, where are you going to go? up 2 over 1, right? And just keep doing that the entire time. Now, you can plug it into a table if you want. That's completely up to you. You can use -1, 0, and 1 and make it look something like this. That's okay. I have no issue in that. Okay? Pick numbers, but if you're going to use a table, pick numbers that are easy to work with. Do I want to pick like 5 and 27 and 32 and -64? No. Pick numbers that are nice and neat and easy. Okay? Pick numbers like 0. Pick numbers like a +1 or a -1. And then just plug it in as you go. Okay? Or use slope-intercept form. Start at -3, go up 2 and over 1, go down 2 and back 1. Okay? Work smart, not hard. If you don't have to put it in a table, don't put it in a table. Now, in some cases, you may have to. That's okay. So, last thing. If it's in linear form, it's going to have basically a power of your x value is going to be a power of 1. Anything else is not linear. It's that simple. Okay? Or if it's 0, if it's just y equals a constant, then it can still be a straight line, but it either has to be 0, a power of 1, or 0 for it to be a straight line and for it to be linear. So, like, is this linear? No, why not? To the second power, right? It's a quadrilateral. It's a parabola. Okay. Now, if we evaluate, all we're going to do if we evaluate for -1, that just means plug and chug. Now, make sure whenever you do this, that whenever I plug and chug, whoop, wrong one. Write it out, -1 squared -3 times -1 plus 5. Okay? It's not linear because of that too, because it's to the second power. So now, working with PEMDAS, right? Some of you, I think you made silly mistakes on the test. Do this part first. What's -1 squared? 1. So it's 1 in here. What's -3 times -1? Plus 3. And then plus 5. So, -1 plus 3 plus 5, +7. Okay, some of you would have tried to distribute that negative first. Remember, exponents, parentheses, exponents, multiplication or division, and then adding and subtracting. Don't make silly mistakes.